Okay, we're going to do the erosion, deposition, and moving water lab. This one you're going to have 3 different varieties. First we're going to start with a gentle slope, then we're going to move the sediments back up, and we're going to start with a steeper slope, and then we're going to have a steep slope at the head, so at the beginning of the stream, and no slope at the mouth, which is the end of the stream. You are going to be looking at what is going on during the video. We're going to start with January. We're going to use the volume of water flow that we'd have from January to December. You're going to be looking to see how much erosion you have, how much deposition down at the delta do you have, how does the channel shape change over time. And after we're done running January through December, I'm going to need you to draw what you see in the gentle slope. So you're going to make a rectangle and label it gentle and do a little drawing the best you can. I get it because it's got a video. Then you're going to do another rectangle, steep slope, same thing, and do a drawing. And then steep slope at head, gentle slope at mouth, do your third drawing. I am going to give you measurements to actually add to your picture. Okay? I'm also going to post a picture at the end of the gentle slope, of the steep slope at head, and no slope at mouth. So you can look at those too. The drawing here is do the best you can, but try to put the measurements on. Okay? Then we're going to take that, going to answer questions. Question number 1, walk me through 2 months at a time. January and February, how much erosion, how much deposition, how did the channel change over time. Then go March, April, link those together. How much erosion, how much deposition, what size sediments did you see moving, what was happening to the delta. Go through December. All right, and yes, you have to do the related problem. Okay, here we go. All right, to begin, what we're doing is I'm putting sand. You'll see the tape. So my tape is approximately 48 centimeters from the top to the tape. So that's how much sand I have. And then if I'm looking at the average depth of my sand, oops, let me do it on this side so you can see. Average depth is approximately 3.8 centimeters. Okay, I looked at this at various points, so they're all about the same. What we're going to do is going to get the hose here. We're going to go January through December. We're going to measure everything from after the tape, because anything after the tape is going to be our delta. All right, let's go. Okay, here we are at the gentle slope. We're going to start with January. I need you thinking January and February here in Central New York most of the time. Our water that's moving through our streams, the volume is going to be a little lower, or the velocity is going to be a little lower because some of that water is frozen. So, every 30 seconds, another month. Here we go. Just got to get January started. January is a low flow. If you're looking at January, you'll notice you do have some erosion, but it's the smaller size sediments that are eroding. And yes, you are depositing sediments and you're starting to form your delta. Over here, you're starting to undercut the bank. So what's happening, there it goes. You're cutting underneath, the top becomes unstable, and then it just drops. Okay, we're in February. Okay, we're getting ready to go to March. March is what? The beginning of spring, and we have that meltdown on your snow. So with that meltdown on your snow, I definitely have a greater volume of water flowing through. with that greater water flowing through, I have more erosion. Now notice, I'm also getting erosion on the other side. Also pay attention what size the particles are being moved. There went a larger particle. Okay, getting ready for April. It's the end of your snow melts. So March and April, you're going to have a higher volume, higher velocity, more erosion, larger size particles that you're moving. Now over here, if I'm looking, if this stream table was wider, you'd get a nice meander going here. Unfortunately, the stream table is not wider. Okay, I'm getting ready for May. May, my temperature is increased. So as my temperature increases, I have more evaporation. So my volume's going to go down a little. If I'm looking at that one, notice my size of sediments are just a little smaller than they were for March and April. I'm still eroding, and I'm still depositing on the delta. I'm getting ready for June. June, higher temperatures even more. So I have more evaporation, so less water flowing through, yes? These look like some of the rocks that if you were watching the stream video that you'd see in the video. They're causing what? Their water to have to figure out which way to move. Okay, we're in June. June, higher temperatures, so my volume is going to decrease because I have more evaporation. Now with that, notice only the smaller size particles are moving. I'm not wearing away at my delta wearing away at my banks like it was before. I'm getting ready to move into July. I'm going to link July and August together. Higher temperatures, even more. So that means even more evaporation, so my volume is going to go down. Oops. I'm going to leave July and August the same. We're coming into September. September, if you've been here, it's still a little warm. So we're going to bring it up a little more to what it was in June, because my temperatures have dropped a little bit, especially by end of September. So I brought it back to what we had in June. October, November getting ready to come. October, November, temperatures drop, less evaporation. So that means I have more water. More water means a higher velocity. Means more erosion. Okay, I'm leaving November, about the same thing as it was for October. Getting ready to move on December. December, I'm going to start bringing it down a little because towards the end of December, sometimes we start accumulating ice or start building up ice a little. All right, so if you notice, it's only the fine size sediments that are moving. All right, 10 seconds left. After the 10 seconds, our year is done. I'm going to shut the water off. I need you looking at the shape, doing your little drawing. Whoops, wrong direction. Remember, anything below the masking tape is your delta. So here's the beginning. This was the mouth area. Anything beyond is your delta. We're going to take a picture after this drains a bit, and then I will do your measurements for you. So right now, get something, preferably a pencil, so you can do, remember, you have 3 rectangles that you're going to be putting on that lab. Okay, I'll be back in a second to measure your depths. Okay, now we're going to measure the length of your delta. So here's the top. Now, from the sheet, you have the top, you've done your drawing, and then we're going to mark where the delta begins, and you're going to draw, here's the left, we're going to say this is your left side. Left side, the length of the delta, the right side of the stream table, the length of the delta, and the middle of the delta. We're going to get the lengths, and then we're going to get the depth of where we measured before, up in the sand, and then we're going to do a couple depths on your delta. All right? So remember, get your drawing in. So if I'm looking at the left side of the delta, my sediments end about here. So if I'm looking, the length of the delta is approximately 18.7 centimeters. Slide over to the right side, and I go all the way down here. So my length of my delta is approximately 44.6 centimeters. Okay, then I'm going to do the middle. Put my ruler here, slide it to the middle. In the middle, it's about 33.8 centimeters. So get those measurements. So the left, the right, and the middle. Now I'm going to come over here and I'm going to do the depth at the top. Now, if you looked, some of our sediments got pushed upwards. So I'm looking about almost 4 centimeters. Coming down here on my delta, I'm going to go at the mouth. The mouth is approximately 1.5 centimeters. I'm going to go to the mouth, what would be over here, about 0.5. I'm going to go in the middle of the delta. .5 centimeters. And then I'm going to go down here at the end. About 2.1 centimeters. Okay, so on your drawing, you're going to add the lengths, left, right, middle, and then you're also going to add the depths up here, and then on your deltas. Okay, make a little mark where your delta begins. Okay, get that done, and I'm going to move the sediments up, and then we're going to increase the slope and make it a steep slope and repeat everything that we just did January through December. And make sure you're looking at and comparing the change in the volume, the velocity, and the amount of erosion. Okay, I'll be right back. Okay, here we're back again. Now we're doing the same thing as we did with the gentle slope, but as you can see, I've increased the slope, so it's going to be a much steeper slope. And we're going to run from January through December once again. I need you looking at the amount of erosion you see and the amount of deposition you see happening and what size particles you see happening, because the volume should be about the same from January as it was last January through all the other months. So it won't be the volume that should change, but it should be the velocity because of the slope. Okay, here we go, starting with January. All right, I need you guys to start thinking, start predicting. With a steeper slope, what do you think is going to happen to the amount of erosion? Is the amount of erosion going to increase? Is the amount of erosion going to decrease? Oh, there goes our bank already. Also moving a larger particle. We didn't move a larger particle last time in January. So obviously, our water's moving a little faster. Coming up to February, remember February I'm going to leave it about the same as January. Because it's low, because we got some frozen water, yes? Okay, in 5 seconds we make to March. Remember March was a lot more volume because we had the snow melts. Okay, look what's happened to that bank. You're undercutting it and the top gets too unstable and it just collapses. Okay, we're in April. There goes that bank. As you can see, the length of the delta, the sediments have gone down a lot further than they did the last time. But you also notice that we, for some odd reason, we did not we did not root on the other side, as we did. So now we're in May, we're bringing it back a little, because temperatures increases. Oh, there we just went with our little rock. So as temperature increases, we have less volume. Getting ready to go to June. In June, I'm going to bring down the volume again. And more of my banks are going. Like I said, unfortunately, the stream table, if it was wider, we get that nice meander going here. We just don't have that wider stream table. Okay, we're moving to our summer months, so that means we're going down in volume because of evaporation. Here we are, July. Well, down a little more. Bank is becoming destabilized. And was collapsing. Notice this time you actually can see the stream table at the bottom. So if I had more sand, you'd have even more erosion because you see the black color. August. Now September, we're going to keep it about the same. Low warm temperatures. Then when we get into October, November, going to bring it back up a little. Temperatures drop. A little less evaporation. So that means a little more volume. if you're looking, you should see that on this one, we got larger particles moving, even on the ones that are not March and April. So obviously, if the slope increases, what happens to the velocity? What happens to the erosion? Need you thinking. As the slope increases, so does the velocity. If the velocity increases, so does the erosion. Okay, we're on December. Last 8 seconds. Okay, get your lab back out. Do your drawing. Okay, we're here to measure the steep slope from looking on the left side of the stream table. So here's the top, here's the left side. At the beginning where the mouth would have been, I don't really have any deposition. That's because it eroded more on the right-hand side. So if I come down, I don't really have deposition until about 16 inches down from the mouth. And then if I look at that, I go to approximately 35. So nothing for the first 16, then from 16 to about 35 centimeters is my delta. Then I'm going to slide over to the right-hand side. The right-hand side, we definitely have a longer delta. If I look at it, my delta actually comes down to here, which is approximately 59 centimeters. Then I'm going to go into the center. Center comes down to approximately 51.5. Okay, so get those written down. Left side, right side, middle on your drawing. Next, we're going to look at we're basically eroded all the way down here. So at the top, I'm at approximately maybe 0.1 or 2 centimeters. I'm going to go down the right-hand side because the left-hand side, I'll go in the middle of it. So at the mouth, at the right-hand side. I'm looking at about 1 centimeter in depth. Going down halfway through. My depth is about 2.1 centimeters. And I'm going down towards the end. And my depth is about 3.2 centimeters. Okay, I'm only going to do the one in the middle on the left-hand side. About 0.4 centimeters. Then I'm coming in the middle. Slide this over a little. about 1.5 centimeters. And down towards the end, about 2 centimeters. So get your depths in. I'm gonna be moving the sediments. I'm gonna get rid of the slope so it's flat on the table. I'm gonna pile all the sand at the top so I have a steep slope at the head and no slope at the mouth. All right, we'll be back soon. Okay, here we are on the last of your drawings. Notice that we have a steep slope at the head of the stream and it's pretty flat where our mouth would be. So steep slope, no slope, and the stream table is flat on the lap table. Okay, here we go. Make a prediction. What do you think about the length of the delta? Is it going to be longer? Is it going to be longer than the steep one? Is it going to be longer than the gentle one? Is it going to be the same as the gentle one? Let's see what happens. So we're starting in January. Here comes January. Notice where our erosion is. It's deep. It's making maybe a V-shaped valley because it's got a very steep slope. Coming up on February. Not a lot of movement on forming a delta. Okay, there goes part of the hillside. Okay, we're coming ready to get to March, so you know that means volume is going to increase. So you would predict that we'd have a little more erosion. Notice what's happening to the inside. There it goes. Becomes unstable. Okay, here comes April. 4 seconds. Notice that even with all this erosion that's happening, that our delta hasn't really gotten that big. Most of the sediments are going and getting deposited where it was flat. Okay, getting ready for May. So May, remember, temperatures increase, volume's going to decrease because of the evaporation. All of our erosion has happened on the front side of our cliff or our hillside. Getting ready for June. Gonna bring it down just a little more. Oops, a little more. Because of evaporation. Okay, into July, bringing it down more. Remember, July and August, high temperatures, more evaporation, lower volumes. Again, look at the size of sediments they're moving. They're the really small ones. August. Get ready to go to September. September, remember, bring it up just a hair. Again, look at what size sediments you're eroding. Notice the delta, not that big. Okay, October. We're going to increase a little more. October, November, I'm going to leave it about the same. Notice the particles are slightly bigger, but they're not anywhere near the last one. Notice that you do not see any little white pebbles. None of that has moved. You're into November. And coming up onto December. December. A little less. Smaller sized particles moving. Two, three, one. Okay, and we're done. It's time for you to draw. Okay, so we're here to do the measurements of your steep slope at the head, no slope at the mouth. So let's look at how far the delta actually got. On the left-hand side, I would say approximately 16.8 centimeters. Coming on the right-hand side, some of that was already there. So I'm going to go about 16 centimeters. And then dead in the middle, about 8 centimeters. Okay, so get your lengths down. On the left side, the right side, and the middle. Now it's time to do your depths. Okay, so let's go depth on the left side at the mouth. About 1.3 centimeters. Okay, so we're here to do the measurements of your steep slope at the head, no slope at the mouth. So let's look at how far the delta actually got. On the left-hand side, I would say approximately 16.8 centimeters. Coming on the right-hand side, some of that was already there. So I'm going to go about 16 centimeters. And then dead in the middle, about 8 centimeters. Okay, so get your lengths down. On the left side, the right side, and the middle. Now it's time to do your depths. Okay, so let's go depth on the left side at the mouth. About 1.3 centimeters. 1.8. All right. Let's go with the depth on the left side around the mouth area. So about 1.8 centimeters. We're just going to go straight across in the middle. About 1.4 centimeters. And on the right hand side, about 1.8 centimeters. I don't think there's enough to measure the others. I do want to mention something really quick, because so that means you have your 3 drawing is done. Looking at one of your questions. Looking at question 4, it says, what is the characteristic of the feature that forms at the mouth of the stream? Well, what feature forms at the mouth of the stream? Well, if you look on your notes, it's the delta. It's not asking what is the feature that forms at the mouth of the stream. It's asking what are some characteristics about it. Is it hilly? Is it flat? Are the sediments sorted? If they are, how are they sorted? Horizontally, vertically, both? Number 5, it asks, what is the pattern of movement of water which flows over this feature? Now, if you look really close, and I was trying to look for this on the other ones, but it wasn't as apparent, you do have what they call distributaries. Distributaries are almost like little tributaries, but they're on the delta. So if I look at the shape, in your packet that I sent home, you have your drainage patterns. Okay, here's the description, and on the back, there are images. If I look at it, this one, they almost look like veins. So this one is going to be more of a dendritic pattern, which makes sense because you have a little higher and then you're going flatter. So that's what question 5 is looking for. And yes, reminder, you need to do the related problem. There are 4 parts to it. If the system was all to dry up, we wouldn't have stream erosion, but what would be able to move those really small size particles? Something that you deal with on almost a weekly basis. And we definitely have it tomorrow before the cold front comes in. All right, if you can't think of it, like I said, email me, send me a comment on your Google Classroom. Good luck, and I will be talking to you again. Good night.